The secret behind avocado, fleece you've never seen, a microscopic exploration into the hidden cells. Scene 1, opening. Today, we're going to do something you've never seen before. We're going to dive into the world of the very small, into the deepest part of this fruit's flesh, and discover an unexpected sight. Tiny, rock-like particles packed together, mysterious craters, strange patches of color, and much more. Brace yourself. This story will change the way you look at avocados forever. Scene 2, highlighter green and deep green. When you cut an avocado open, you'll notice the edge near the skin is a deep green, while the area near the seed is a bright yellowish green, similar to the color of highlighter. Why is this? The answer lies in a pigment called chlorophyll, but in avocados, this chlorophyll isn't evenly distributed. The skin protects the exterior, and the tissue beneath the skin is exposed to more sunlight, so the cells there produce and retain higher amounts of chlorophyll. Therefore, the closer to the skin, the deeper the green. What begins to surface are other pigments called the carotenoids lutein and zeaxanthin, which are greenish yellow. This mixture of residual chlorophyll and carotenoids is what creates the distinctive bright highlighter green color. Scene 3, magical texture, looks dense, feels soft. Avocado flesh looks firm, but when pressed, it feels incredibly soft. The secret lies in the smallest components of this fruit's flesh, the parenchyma cells. These cells resemble thin-walled bubbles, tightly packed together without any gaps. Inside each bubble is a large droplet of vegetable oil and a few starch granules. Because the cell walls are thin and not hard, when pressed, the cells easily burst and the oil releases. This creates a creamy, soft, and melt-in-your-mouth sensation. Scene 4, microscope reveals cream white and dark gray colors. When very thin slices of avocado flesh are viewed under a microscope at low magnification, the highlighter green disappears. Instead, the two dominant colors, creamy white and dark gray, appear, as we've seen so far. Why? Because we're only seeing 1 or 2 layers of cells. The total amount of green pigment per field of view is very small, too little for the eye to perceive as green. The creamy white color actually comes from colorless, clear oil droplets that fill most of the cell's volume. They reflect the light of the microscope, making it appear bright. And the dark gray color? That comes from areas where the cell walls are thicker or the cells are more tightly packed. Scene 5, orange spots, khaki red particles, and white core stone particles. Between the creamy white and gray, bright orange spots emerge. These are accumulations of carotenoid pigments, beta-carotene, lutein, collected in organelles called chromoplasts. Surrounding these orange spots, we see dark red particles. These are cells containing tannins, or phenolic compounds. Tannins in avocados can give them a reddish-brown color, especially when slightly exposed to air and begin to oxidize. Then the small, stone-like structures have a creamy white core and a thick, dark gray rim. These are what are scientifically called brachysclerides, a type of cell whose walls have thickened with lignin. The white core is an empty cell cavity or one filled with little plasma, while the dark gray rim is the thick, lignified wall. These stone cells are what sometimes, without us realizing it, give the avocado a slightly gritty sensation when we chew. Scene 6. Why are there only a few green spots on the microscope? The inner avocado flesh we typically eat, which contains the most oil, is actually very poor in chloroplasts. Chlorophyll-bearing chloroplasts are most abundant in the outer layer, near the skin, and around the vascular tissue. The green spots visible under a microscope are simply remnants of these chloroplasts. Scene 7. Light black spot, oxidation trace. If you've ever left a cut avocado uncut for too long, you're familiar with the dark brown color of its flesh. Under a microscope, the same process occurs on a smaller scale. The light black spots we see are the result of enzymatic oxidation. Avocado flesh contains polyphenol compounds and the enzyme polyphenol oxidase. Once the cells are damaged by cutting, the enzyme combines with the polyphenol and oxygen from the air, producing a brown to black pigment called melanin. Sometimes, Aggregations of tannins or dead cells also contribute to this dark appearance. Scene 8. Maximum zoom, closed rock particles, and mysterious craters. Zooming in even deeper is what we see now. Look at the cluster of stone cells we mentioned earlier. They're packed together like tiny, tightly packed stones. Surrounding each stone cell, in its walls, are depressions that resemble small craters. These are parts of the stone cell called pits. Pits are microscopic channels in the very thick cell walls, allowing the exchange of substances between cells despite the walls being nearly impenetrable. Scene 9. Nutritional content and benefits from the microscope to the human body. Avocado flesh is a complete package. Its monounsaturated fats, especially oleic acid, are good for the heart. It's high in fiber, aiding digestion. It's even higher in potassium than bananas, helping with blood pressure. Vitamins E and C nourish the skin, while lutein and zeaxanthin protect the eyes from damage. Folate is essential for cell regeneration. Tannins and polyphenol act as antioxidants. Even the remaining chlorophyll can aid in mild detoxification. So, every spoonful of avocado flesh is a gift from the millions of cells we've just observed, working together to provide benefits. Scene 10. Closing. Lessons from the unseen. We have begun our journey into the cell. We have learned that something as seemingly simple as a piece of avocado flesh actually holds incredible complexity when we dare to look closer. Don't forget to like, subscribe, and share with those around you. See you in the next microscopic exploration.